Class 12th subject mathematics chapter application of derivative continued. Good morning class. Today we will discuss new topic under application of derivative as increasing and decreasing functions. So you will describe with the help of differential calculus as application of derivative how to find whether a function is increasing or decreasing with the help of differential. So first we will define in general what is the definition of increasing and decreasing function. So here you have to see the definition I have written. Increasing function, a function fx is said to be an increasing function of x if for every x2 greater than x1, I have taken two real numbers x2 and x1, and the condition is for every x2 greater than x1, if it implies fx2 is also greater than fx1, then fx is said to be increasing function. That is, greater value of x must have greater functional value. The example I have shown here, let fx equal to 3x plus 1 and I take x2 equal to 3 and x1 equal to minus 1. So clearly 3 is greater than minus 1, that is x2 is greater than x1, you have to apply that definition. So f3 is 16 and f minus 1 is 4, and you know 3 is greater than minus 1 is implying here f3 is greater than f minus 1. Functional value at 3 is greater than functional value at minus 1. As you know, 16 is greater than 4, which implies, therefore it is increasing function of x. Similarly, you will define decreasing function. Keep a function fx is inversely proportional to x. That is, a function fx is said to be decreasing function of x if for every x2 greater than x1 implies fx2 is less than fx1. Here it is just reverse. For x2 greater than x1 must imply fx2 is less than fx1. That is, greater value has lesser functional value. That you have to show. For example, I have taken fx equal to 1 upon x where x is non-zero, and let x1 is 2 and x2 is 4. So clearly 4 is greater than 2, that is x2 is greater than x1, but fx2 is 1 by 4 and fx1 is 1 by 2. And clearly fx2 is less than fx1. As you know, 4 is greater than 2, but f4 is less than f2, that is 1 by 4, as 1 by 4 is less than 1 by 2. Therefore, fx equal to 1 by x is always decreasing function of x. So these are algebraic definition of increasing and decreasing function. Now you have to use, since this chapter is under application of derivative, so you will be using a theorem which I have highlighted as, if fx is an increasing function of x, then f dash x should be greater than 0, and if fx is decreasing, then reverse, f dash x should be less than 0. Meaning, if derivative is positive, then function is increasing. If derivative is negative, then function is decreasing there. So its proof is also asked. So I have written the proof. Let y equal to fx and let delta x is a small increase in x which is greater than 0. Then clearly x plus delta x is greater than x. And if fx is increasing, then fx plus delta x is greater than fx, or fx plus delta x minus fx is greater than 0. That is clear. Or dividing by delta x and then taking limit delta x tends to 0, fx plus delta x minus fx over delta x is greater than 0, which is equal to f dash x, the left hand side. Both sides we are applying the limit delta x tends to 0 in class 11. You know, limit delta x tends to 0, fx plus delta x minus f dash x over delta x is greater than 0, but this left hand side is called derivative of the function by definition. So we have proved f dash x is greater than 0, and that is what we have to use, and we have proved it. Similarly, with the help of this, you can prove if fx is decreasing, then f dash x is less than 0. The same way, only greater sign will be converted into lesser. And this is the criteria or application of derivative to find fx increasing and decreasing, or either increasing or decreasing depending upon its nature. So behavior of the function can be determined by derivative with the help of f dash x greater than 0 and f dash x less than 0. Like I have taken here one example, so that fx equal to x cube upon 3 plus 4x square plus 18x plus 1 is always increasing. So answer for every real value of x. So if you will find derivative, that is f dash x differentiation, then it is x square plus 8x plus 18, and after simply, we can rewrite f dash x as x square plus 8x plus 16 plus 2. 18 I have broken as 16 plus 2. So this is f dash x as x plus 4 whole square plus 2. X plus 4 whole square is always positive. As you know, square is positive always for every real value of x, and 2 is also positive. So in all, f dash x is greater than 0 for every real value of x. That is, x belongs to R, hence fx is increasing function for all real values of x. So this way you can test with the help of derivative. Make a note of it and show it to me.